functions. Let x and y be two non-empty sets, such that there is a relation from x to y. The relation from x to y is called a function. If each element in x appears as a first projection only once in the ordered pairs of the relation. In this example, x equals the set of 1, 2 and 3. Y equals the set of 2, 4, 6 and 8. R is the relation from x to y, such that R equals the set of ordered pairs 1, 2, 2, 4 and 3, 6. Since each element in x appears as a first projection only once in the ordered pairs of the relation, this relation is a function. X is called the domain. Y is called the codomain. The set of images 2, 4 and 6 is called the range of the function. Solved problem number 1. If f is a function from the set of 1, 2, 3, 4 and 5 to the closed interval 2, 6, and if f of x equals x plus 1, determine the range of this function, and draw its graph. Solution. Since f of 1 equals 2, f of 2 equals 3, f of 3 equals 4, f of 4 equals 5, and f of 5 equals 6. Therefore, the range of the function f is the set of 2, 3, 4, 5 and 6. This graph represents the function f of x equals x plus 1 from the set of 1, 2, 3, 4 and 5 to the closed interval 2, 6. Solved problem number 2. If f of x equals twice x, when x is greater than or equal to 2, and f of x equals x plus 2, if x is less than 2, find f of negative 1, f of 0, f of 1, f of 2, and f of 3. Then, graph the function. Solution. Since negative 1, 0 and 1 are all less than 2, therefore, f of negative 1 equals negative 1 plus 2 equals 1. f of 0 equals 0 plus 2 equals 2. And f of 1 equals 1 plus 2 equals 3. Since 2 and 3 are greater or equal to, therefore, f of 2 equals 2 times 2 equals 4. And f of 3 equals 2 times 3 equals 6. From the graph of the function, we deduce that the range is the set of rational numbers R. Operations on functions. If f1 and f2 are two functions of domains d1 and d2, respectively. And D1, intersection D2, equals D. Then 1. F1 plus or minus F2, of x, equals F1, of x, plus or minus, F2, of x. For every x, in D. 2. F1 times F2, of x, equals F1, of x, times F2, of x. For every x, in D. 3. F1 divided by F2, of x, equals F1, of x, divided by, F2 of x. For every, x in D. Difference, the set of zeros of, F2, of x. Solved problem number 3. If f is a function whose both domain and codomain equals r, and f of x equals x plus 1, g is another function whose domain, the closed interval, -3, 5, and whose codomain, r. G of x equals to x minus 8. Find f plus g of x and f minus g of x. Solution 1. F plus g of x equals f of x plus g of x equals x plus 1 plus 2x minus 8 equals 3x minus 7. Where f plus g of x is a function from the closed interval -3, 5 to r. 2. F minus g of x equals f of x minus g of x equals x plus 1 minus 2x plus 8 equals -x plus 9. Where f minus g of x is a function from the closed interval -3, 5 to r. Solved problem number 4. If f is a function whose both domain and codomain equals r, and f of x equals x plus 2, g is another function whose domain, the closed interval, -8, 8, and whose codomain r. G of x equals x minus 2. Find fg of x and f over g of x. Solution 1. Fg of x equals f of x times g of x equals x plus 2 times x minus 2 equals x squared minus 4. Where fg of x is a function from the closed interval -8, 8 to r. 2. F over g of x equals f of x over g of x equals x plus 2 over x minus 2. Where f over g of x is a function from the closed interval -8, 8, difference the set of 2 to r. Monotony of functions. Increasing function. The function f is called increasing on an interval a, b. If, when x1 is less than x2, f of x1 is less than f of x2. For every x1 and x2 belonging to the interval a, b. Example. To check the monotony of the function f of x equals x minus 1, whose domain is the closed interval 2, 6. Let x takes any two different values belonging to the closed interval 2, 6, like 3 and 5. F of 3 equals 3 minus 1 equals 2, and f of 5 equals 5 minus 1 equals 4. Obviously, 3 is less than 5. And f of 3 is less than f of 5, which fulfills the condition of increasing functions. Now, let us obtain the same result by graphing that function. Notice that f of x is increasing on its domain. Decreasing function. The function f is called decreasing on an interval a, b. If, when x1 is less than x2, f of x2 is less than f of x1. For every x1 and x2 belonging to the interval a, b. Example. To check the monotony of the function f of x equals 5 minus x, whose domain is the closed interval 0, 4. Let x takes any two different values belonging to the closed interval 0, 4, like 1 and 3. F of 1 equals 5 minus 1 equals 4, and f of 3 equals 5 minus 3 equals 2. In this example, 1 is less than 3, but f of 3 is less than f of 1, which fulfills the condition of decreasing functions. Now, let us obtain the same result by graphing that function. Notice that f of x is decreasing on its domain. The constant function. The function f is called constant on an interval a, b. If f of x equals a constant real number, c, for every x belonging to the interval a, b. Example. The function f of x equals 4, whose domain is the closed interval 2, 6, is represented graphically as shown below. Notice that f of x is constant on its domain.